Today we're talking about inscribed angles, and an inscribed angle is any angle that is written inside of a circle. So wherever the corner is, let's say you're talking about this angle, that would be on or inside the circle. So we are going to call that an inscribed angle, whereas if you look at this other angle that we have drawn here, that is not an inscribed angle in the same regard. But it is an inscribed angle in the sense that its corner, or angle C, is on the inside of the circle. So we do treat these two types of angles differently. However, also to be mentioned would be that they both intersect at the same spots, and on the circle we call this an arc. So while there are two different angles, there is only one arc being made. I mean, of course, you could go backwards, I guess, and say that A to B is an arc that way, but we're going to look at an arc in the sense that it should be kind of facing on the inside here. Okay? So this first one says, if an angle is inscribed in a circle, then its measure is, and so I have the inscribed angle written inside, and it intersects at D. This angle is half the measure of the intercepted arc, and that's going to be from here to here. So we would say that the measurement of angle D is half of arc AB. So let's say you're given an inscribed angle and an arc, and you are going to have to find the degree measure of the opposing piece. So looking at this first example, we are given the angle, and it is 80 degrees. So we will need to find the arc that is formed by the intersections of the end of the angle. And so if you recall on the last theorem, the angle is the small piece. Okay, now I know the half is over here with that number, but it's because, like, if I let this be 50, this angle has to be 100. Half of 100, you have to take half of the big number to make the small number. So with that in mind, we're saying the angle is the small piece. That would mean that angle S, measurement of angle S rather, is 1/2 the arc PQR. Alright, and we know the angle is 80. Solve for X. If we divide by 1/2, we get 160. Which you realize is also double the small angle. So you could think of that two different ways. You could think of taking half of the bigger number, or you could think of doubling the small number. I find if you write an equation for it first and plug in, you'll never have this guessing game, and you should get it right if you know how to divide. So for the next one, it says find the measurement of angle. We're given the angle sign this time. Angle, and then N is in the center. Now remember, we said the angle was the smaller piece before, so you might already know the answer by looking at this 88. But let's just go ahead and plug it in. The measurement of angle MNP is half of the angle, which is from M to P. That's an arc. We don't know the angle. We do know the arc. So if you said the answer was 44, you were right. The second theorem I want to talk to you about is if you have angles that intersect at the same arc, then that means that those angles are congruent. And what I mean by that is, let's say you're talking about arc AB. Okay, now we need to figure out what angles form that arc. And that's going to be any line from A, so let's just say here, and to B. Now they have to connect, so we could have chosen this line, but that doesn't connect at D, so that wouldn't be an angle. So there was another choice. If we go down this route and go through here, acting like C to B goes underneath A to D, then we would say that these two angles are congruent. Now when solving a problem of this type. Your eyes might kind of play tricks on you and make you see two triangles in a circle. And I would rather you try to think of it as two V's in a circle. So let's see, where's the first V at here? It says find angle Z. Okay, well that right there's the angle, and that's at Z. So the first V looks like that, and then we can see our arc from X to W. Okay, well they gave us this angle over here, that's angle Y. You can see that kind of leads up to the same 2 points at X and W. So since they form the same arc, that means they're congruent. The measurement of angle Z is also 62 degrees. This one's a little wordy, so I went ahead and filled it in, but basically what it's saying is if you have a right triangle, then that means you have a side, or specifically the hypotenuse, as your diameter. Okay, and then the 90-degree angle, since I drew that in there, the reason I knew that was the 90-degree angle is this will also always be the hypotenuse in this situation, and we always know that the hypotenuse is always opposite the 90-degree angle anyway. So you see this example here, we check and we have a triangle with a diameter as one of my sides. Right away I can put a 90-degree mark there. So 2x equals 90. Divide by a 2. X equals 45. And the last theorem for inscribed angles says that a quadrilateral can be inscribed just like a triangle can. Quadrilateral just meaning we're adding a side, and now there are 4, can be inscribed in a circle if and only if the opposite angles, so that would be like E and G or D and F, opposite meaning catty corner, they are supplementary. So what does supplementary mean? It means that they add to 180 degrees. So let's take these two that we've already marked, D and F. That means that the measurement of angle D and the measurement of angle F equal 180, as do the measurement of angle E and the measurement of angle G. If we were told to find X and you had 3 of your angles, you could do it. If you can identify what the opposite angles are, so let's see, which one should we choose first? Obviously X, that's the one in order to answer the question. So which one's opposite that? It's kind of hard to see on this one. Let me put a center in for you. You can't really tell, when it's a box, obviously cross, it's a little easier to tell. So maybe you can just say every other. So if we skip 34, we skip 36, we wind up with the same guy, and that's 29. And what's supposed to be true about this, since it's inscribed, is that those two together equal 180. And if I solve by subtracting 29, remember we need it to cancel on one side to get X alone. We subtract here, that's kind of like subtracting 30, so that would be like 150. And we're 1 short, so we need to make that go up by 1. X is 151 degrees. And if you chose these other angles just by chance, they should also be, let's check, 34 plus 146, 180. Let's see, so 4 and 6 makes 10. So far so good. Carry 1, 3, 4, 5, 6, 7, 8. Alright, so that concludes today's lesson. Go online and finish the Pearson assignment. Make sure you submit it to Canvas with a screenshot. If you have any questions, send me a message. We're almost there, guys.